Welcome to the Gestalt IT Roundtable podcast. I'm Stephen Foskett, your host, and today we are in Denver, Colorado as part of Storage Field Day 13. I'm joined by a group of storage folks, and one of the topics that keeps coming up is NVMe. As Ray said, this is the new world order. NVMe will wipe away everything that we've known and take over all of storage. Or maybe not. So my question for you guys is, what do you think? Is this just another protocol, or is this going to fundamentally transform storage? Ray?
It will fundamentally transform storage. I mean, anything that can do millions of IOPS at hundreds of microseconds of response time, how can you not say this is going to transform storage? SSDs came along and they were able to do 1 millisecond response times and hundreds of thousands of IOPS, and they transform storage. Today, it's hard to find disk storage out there anymore.
But did SSDs transform storage? Because you just said SSD. SSD is fundamentally a fake disk drive. Fake disk drive, that's not a transformation. That's just a fake thing that's pushing the existing stuff forward.
SSD is solid-state device, not state.
Well, SSD was kind of, let's say, increasing the IOP speed, the speed of the drives was getting rid of the physical boundaries of speeding drives, but still you were stuck with the SATA and SAS protocols in terms of queue depth and parallelism. With NVMe, you can in theory really increase and really massively parallelize the bandwidth and get a much higher throughput that you can get with SSD.
Bandwidth, it's IOPS, it's response time. It's going to change our world.
I think that's correct. I mean, SSDs, you talk to any storage administrator, anybody who's speccing application performance, they change the way that they consume storage. I don't think NVMe is going to, within 2 years, do it like SSD or Flash did, but I think we're going to hit boundaries where we've got to have something like this.
We look at Flash, I mean, it's been going on for 10 years. I mean, it's been long time in gestation. NVMe has the advantage of having pretty much all that Flash stuff in front of it. So they've optimized the response time, they've optimized the storage, they understand deduplication and compression and those things that make it more economical. And all we've done now is we've swapped out the interface to that device.
But do you think it's worth it to see all these storage manufacturers go, look at us, we've added NVMe to the next generation platform?
Exactly. Is this just going to be the new yank out the disk drives and throw in the SSDs and call it a day? Or is this really going to be transformative?
Something that does an order of magnitude faster response time, 2 or 3 orders of magnitude more IOPS and more bandwidth is going to change your world.
It looks like some companies more of a slow burn to go to NVMe, while other companies like Pure are just throwing it in there all at once.
Mm-hmm. Mm-hmm. Yeah, and that's, I guess, well, the question is, and I'm being the devil's advocate, Ray, of course, but the question is this just a new protocol? Is this just faster? Because if you're talking transformation, I think that means a different architecture for storage.
I think when you start talking about orders of magnitude difference, from 100 to 1,000 to millions, from millisecond to 100 microseconds.
And that's what happened with Flash. That's what happened with SSD.
It's a significant change. It's going to enable applications that you never really thought of doing before. It's going to enable a different way of doing business. It's going to restructure the storage industry, in my mind.
And probably it requires also the manufacturers to re-architect their products, because this is working in such a different way that you cannot just keep relying on refreshing your product line, because you are used to, let's say, you had HDDs, then you went to hybrids, then you retrofit that to be an all-flash array, but this was still using kind of the SAS or SATA protocol.
Same architecture.
Exactly. And with NVMe, you need to change things to work totally differently. And we see that with what, for example, Intel is doing with the SPDK, exactly, with their kits. So
in the past, there was an isolation between the back end and the front end. The front end protocol was always, fiber channel or Ethernet or things of that nature. The back end was always SAS or SATA. This NVMe, because of the speed requirements, is going to require the change throughout that whole architecture now. You're going to have NVMe over fabric to NVMe drives, and the memory structure is going to be different. It's a new world. It's a new world order.
Do you think in 3 years you walk into traditional enterprise IT data centers, the ones that are still there and not in the cloud, I guess, do you walk into those and they're doing things very different than today just due to NVMe?
So what happens with these new world orders? They get layered on top of the old world order. I mean, you still have mainframes out there. You still have tape structures. You still have DASD, which is a mainframe disk environment, VCKD, and all those things. Those things still exist. They'll never go away because there are applications that were developed on them and continue to use those things. But what will happen is the new application development will start taking advantage of the NVMe structure. Not unlike, as client server came along, new applications were developed for a client server architecture. The cloud is coming along, applications are being developed specifically to run in the cloud. There'll be applications that are developed that you don't even understand how to work yet. We develop with NVMe.
Is NVMe the architecture of the cloud, or is it the architecture of the next wave of computing?
Yeah, using NVMe in the cloud is a different animal in my mind. I think it's primarily on-premises infrastructure. If I said that right,
yeah,
good.
Am I good?
You're good.
Yeah.
And well, that's actually a good point. So, if you've got NVMe, what's going to need all that bandwidth? And we discussed that, with Pure Storage, with the FlashBlade. I think that they hit on a real good use case for NVMe and NVMe fabrics, and that is all this new AI, machine learning. That basically it needs super high throughput. It needs lots and lots of parallelism.
The surprising thing for me in that Pure discussion is they really talked about the AI as an application for the FlashBlade, which is not NVMe yet.
That's interesting. That's a real good point.
And there are applications I think can take advantage of the bandwidth today and the millions of IOPS and those sorts of things. But I really think that what's going to happen here is that's going to be the new baseline of infrastructure that's out there, and you'll see applications developed specifically for those environments, whether it's AI training or not.
I agree with that. I think my question is, being on the partner side for so long till recently, is Flash came and took over because it simplified storage arrays and storage management. It took a lot of performance configuration and modeling out the window. And if we look at NVMe and things like AI and machine learning, which I think are two things people just throw at whatever new, fast, big, scalable thing they want to sell, but let's assume, we're not going to see that shift in 3 years where everything goes, we may see it where everything goes that way, but are we going to see organizations consume it like that, or is it just going to be the new fast array? Because I think it's both. No,
it's definitely both. I mean, you can incorporate things like NVMe as a front-end cache to SSD, or
yes,
or in a hybrid environment, however you want it. But in the end, it's
going from spinning drives to solid-state drives is such a huge difference for enterprises, for anybody using it. They saw the difference, and then going from SSDs to NVMe, they might not see as much of a difference until applications catch up.
Let's say that the adoption is also going to ramp up like it used to be for Flash, because NVMe has a cost. It's very efficient, but also it's expensive. So you would see organizations adopting that maybe for the most critical workloads. It can be used for AI. It can be used for image recognition. It can be used for whatever requires, as you were saying, very high throughput of data and very low latency. For example, real-time applications such as financial markets, for example, could benefit from that. But you could also run, let's say, some very heavy Oracle workloads on that, but in the end, it also comes down to, the costs versus benefits, at least in the first stage, while we are still ramping up to this adoption.
Back to the question about whether there's a place for NVMe in the cloud. I think there is. Not unlike there's a place today for SSDs in the cloud. You could configure an EC2 with SSD types of performance. You should be able to ultimately be able to configure some application in the cloud with NVMe types levels of performance. So from that perspective, I think that makes sense. But
I'm thinking things like AI training, for example. That's an excellent cloud application that's not happening yet, and could use massively parallel.
Google's got
storage.
TensorFlow and stuff like that. You can use to train and stuff.
Yeah.
So it's an emerging application. It requires a lot of bandwidth. Requires a lot of computational complexity.
Well, another thing that you brought up, Ray, was there's the new world order in terms of storage architectures. There's also the new world order in terms of storage companies. And that's one of the things you mentioned a minute ago, which is that this is going to transform the face of the industry.
Look what happened. What has happened over the last decade with respect to flash storage. We've had dozens of startups come out and to some extent take over a lot of that market space. Now what's happening is those bigger companies are acquiring the smaller companies and starting to use those as a vehicle to capture that market share. And we're going to be talking to more of them today. You know, we talked to Pure to some extent, but you know, Nimble just got acquired by HPE. These companies will come up and they will rapidly grow into a space that doesn't even exist today. And over time, either the main storage players will understand that technology and go after it themselves, or they'll go after acquiring the technology.
And I am of the impression that they're already looking at acquiring. I mean, I think EMC maybe acquired the SSD too soon.
Yes.
Too soon for the market, too soon for the product, too soon for the company. But I'm pretty sure that you're right, that the big companies are going to be looking out there. They've got these companies on their shopping list.
And why not? Why wouldn't they? And at this point, they're still relatively cheap. In the next 2 or 3 years, when they've got a marketplace of $500 million revenue, it's a different game.
Well, let me give the last word to Brandon. Are you convinced? You came in here, you said, well, I'm an outsider to this conversation. I know something about the technology. Now that you've heard these folks talk about it, what do you think? Do you think this is a revolution?
I think it will be. I think it's just going to take some time for applications to catch up where people have a need for it.
Mm-hmm. Okay. So he's, that sounds a little wait and see to me. I guess we'll wait and see. So this, this is the On-Premise IT Roundtable. Thank you so much, guys, for joining us. Those of you listening on your favorite podcast application, thank you for joining us. Please subscribe. Also, check out gestaltit.com for more news and information like this. Check out our newsletter. We're on Facebook, too. If you go to facebook.com/gestaltit, you'll see a video of this demonstration if you want, or this discussion, if you want to see what we all look like. Pity your taste, but there we go. And we look forward to having you join us again for the next On-Premise IT Roundtable podcast.